All right, hi everybody. So today we are going to be looking at chapter 2.2, trigonometric ratios of any angle. So it's a couple things that we need to know before we get started. And the first thing that we're going to look at is how we can use our sine, cos, and tangent ratios to help us determine the ratio of any angle given between 0 degrees and 360 degrees. So if we look at the diagram that's given, we're given a point x, y, and if we look at x, y, so that's this point right here, okay? So basically the terminal arm is at length x, y. If we wanted to determine the ratio of sine, let's say, we should know that sine equals opposite over hypotenuse. So in this case, if we're looking at sine of theta, which is right here, the opposite side is y, and the hypotenuse is given as r. Okay, so the opposite side is the length of y. Okay, and this is labeled y because the distance of that arm would be measured in terms of the y-axis. Okay, we could also find cos of theta, which is adjacent over hypotenuse. So the adjacent side of theta is x, and the hypotenuse, again, is going to be r. And the last ratio we can work with is tan, which would be opposite over adjacent. And in that case, the opposite side would be y, and the adjacent would be x. Okay, so you can use these ratios to help determine the ratio of any reference angle or any angle. Okay, an easy way, usually when we're working with just like primary trig ratios with a 90-degree angle or a right triangle, we usually remember SOHCAHTOA. So sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. When we're working with reference angles, what we're going to remember is SIR, Coxer, Tix. So sine is always going to be equal to the ratio of y over r, cos is going to be x over r, and tan is going to be y over x. Okay, so another thing that we need to know, I guess, before we get started is we're going to work with the acronym ASTC, which, if you want to help remember, can be all students take calculus. So you have to think back and remember that in this quadrant, this is quadrant 1. We work in counterclockwise. So this is quadrant 2, quadrant 3, quadrant 4. Okay? We want to remember these quadrants and these, and then that SIR, Coxer, Tix, and that will help us determine the sign of the ratio, so whether it's a positive ratio or whether it's a negative ratio. And what I've tried to do here is to create triangles in each quadrant, and each of the segments has been broken down into a red color or a green color. Each green color represents a positive value, and the red segment, equals a negative value. So in this first quadrant, you can see that x would be measured in a positive value as well as y. So this point here would be a positive value and a positive value. That means for any ratio, we're going to have a positive number over a positive number. So in the first quadrant, all ratios are positive. Okay, so sine, cos, and tan are all going to have positive ratios. Moving into the second quadrant, okay, we have our x value is negative, okay? Our y value is positive, and our r value is going to be negative. So if we think back to our SIR, Coxer, Tix and write out all of those ratios, what we would find is that sine is going to be positive. All of the others are going to be negative. So cos would be negative and tan would be negative. Moving into quadrant 3, x is going to be negative again, y is also going to be negative, and then r would be positive. So if we put those positive and negative values into each of our Sir-Cox or Tix ratios, what we would find is that we are going to have, tan is going to be the only positive value, okay? And in the last quadrant, hopefully you see the pattern and how our acronym is falling into place here. So our x value is going to be a positive value, y is going to be a negative value, and r will also be a negative value, leaving cos being the only positive ratio. So tan and sine would be negative in that case. Okay? So let's take a look at some examples here. So if point -5 and -12 lies on the terminal arm of angle theta, find the exact ratios for sine theta, cos theta, and tan theta. So what we need to do here is we need to sketch what this triangle would look like. So we're told that -5, -12. So this is our x value, this is our y value. So we're going to go down to -5 for x and -12 for y. And that's where our point is going to be. That lies on the terminal arm. Remember, the terminal arm extends from the origin. So we're just going to draw a triangle connecting that up to our x-axis. Okay, now we need to find the exact ratios for sine, cos, and tan. So basically, this segment of our triangle is going to have a length of -5. This segment of our triangle is going to have a length -12. We need to figure out what the hypotenuse is going to be. Okay, and what we can do is use a squared equals b squared, a squared plus b squared equals c squared, so Pythagoras theorem. And so we can just substitute that in. So we would have -5 squared plus -12 squared equals, in this case we'll label it r squared rather than c. So 169 will equal r squared, take the square root of both sides, and r will be 13. Okay, so now we have all of the values. So x is equal to -5, y is equal to -12, and r equals 13. So to find sine of theta, we're going to take the opposite over hypotenuse, or in this case, the y over the r. So we'd have -12 over 13. Cos theta, we remember Coxer, so it's x over r, so we have -5 over 13. And tan theta would be given as Tix, which is y over x. So -12 over -5, which would equal 12 over 5. Okay, and that's how we solve that type of question. So our next example is, suppose that theta is an angle in standard position with a terminal arm in quadrant 3 and cos theta equal to -3 over 4. What are the exact values of sine and tan? So similar to our last question, but this time what we're going to do, so we're going to work with the information that we're given. So again, we'll sketch our x and y axis. We know that it's going to be in quadrant 3, so down in the bottom left quadrant. And we know that cos of theta equals -3 over 4. So if we think about cos of theta, that's given as x over r. So we know that x is going to have a distance of -3, and r is going to have a value of 4. And that's just been given from the question. Okay? From here, we need to again figure out what this y is going to equal. And to do that, we're going to substitute it in to try and determine what y is. So we take 4 squared equals -3 squared plus y squared. We'll do some rearranging. We get 16 minus 9 equals y squared, plus or minus root 7 equals y. Okay, we know that y is moving downwards, so it's going to be the negative root 7. It cannot be positive. Okay, and then from here we're just going to take our x, y, and r values and find these ratios. So we're asked to find sine of theta, which is y over r. So that would be negative root 7 over 4. And tan of theta will equal y over x, which is negative 7 over negative 3. And then that would just simplify to positive root 7 over 3. Next example, if sine is equal to negative 0.8090, find all the measures of theta that make this true. So first thing that we're going to do is we're going to find the inverse of negative 0.8090. And when we put that into our calculator, we find out that theta equals 54. This is going to be our reference angle. So now we need to figure out what are the measures of theta that will give us this answer. So what we want to figure out So we have to find all of the angles for theta that would make this true. So we know that we're working with sine as a negative, okay? So the only quadrants for which the angles are going to make sense are the quadrants in which sine can be negative. So if we think back to CAST, or all students take calculus, these two quadrants have a positive ratio for sine, okay? Because our ratio here is negative, those two quadrants are not included. So what we need to do is look at these two quadrants, so our 3 and 4th quadrant, 3rd and 4th quadrant, and we need to find out what angle measure has a 54-degree reference angle. So if I just sketch this to give you an idea of what I'm talking about, this is 54 degrees here, okay, and the reference angle on this side would be 54 degrees. So we need to figure out what the two angles are. So from here to here would be 180 plus 54, and that would equal 234. And then from here all the way around to here could be expressed as 360 minus 54, which gives us 306 degrees. So if you put into your calculator sine of 234 and find the angle measure of that, you would find that it is equal to 54 degrees. And then sine of 306 would also equal 54 degrees. Okay, and the last one, similar to some of the questions that we've done before. So what we want to do is try and find the angle given the cosine or sine or tan law. In the first question, we're given that sine equals positive 0.5. What we need to do is take the inverse of that. So we take sine, the inverse of 0.5, and we find that that equals 30 degrees. And what we want to do is we want to find out which measures will have that as a reference angle. So we're working here with a positive value for sine. So that is quadrant 1 and quadrant number 2. So we've got a 30-degree angle here and a 30-degree angle here. we need to figure out what the two reference angles are. So in quadrant 1, theta would just be 30 degrees, okay? And in quadrant 2, we would want this angle measured, which would be 180 minus 30, which is 150 degrees, okay? Question B, this time we're working with a negative value for cos, so we're restricted. So we have to think about which quadrant has a negative value for cos, okay? And if we think back to a few questions ago, cos theta equals x over r. So if we think back, we have to think about which quadrant is going to give us a negative ratio for x over r, okay? In this second quadrant, we're going to have a negative x this way and a negative y going up. Sorry, a positive y, which makes r negative. So this would be positive, this would be negative, our hypotenuse would be negative. Okay, that is the only quadrant that this question has an angle measure for. So to find that, we are going to take the inverse of this, and we find that that equals 150 degrees. So the reference angle that we would use would be 30 degrees.